Good afternoon, participants. Let us start. Vipin sir, are you able to listen me?
Fine.
Okay, fine. So participants, I would like to once again welcome you in this Atal FDP on artificial intelligence in image processing. So now the guest for this session is my colleague, the coordinator of this FDP, Dr. Vipin Kamre. Sir did his MTech from National Institute of Technology, Rourkela. He did his BTech and PhD from Vishweshwarya National Institute of Technology, Nagpur. He is currently working as an assistant professor in the Department of Electronics and Communication Engineering at Indian Institute of Information Technology, Nagpur. His research area includes image processing and related topics, specifically noise estimation and quality assessment. He is currently working on socially impactful topics like, plant disease identification, skin cancer detection, and facial expression recognition and all. He has publications in reputed SCI journals and international conferences. So let us welcome our institute's most young, dynamic, and energetic faculty, Dr. Vipin Kambre, with his topic Techniques of Image Processing, Role in Machine Intelligence. So, Vipin sir, over to you.
Thank you, madam, for such a wonderful introduction. I'll start sharing. Is my screen visible?
Yes, sir.
Okay, if any queries are there, the participants either can unmute themselves or type in chat box. Chat box I'll be checking at the end of the session, so all queries in chat box will be resolved in the end. Any real-time queries are there, they should be communicated by unmuting themselves. Okay, so let's start. So my topic is techniques of image processing, specifically role in machine intelligence. Now, even though the theme of this FDP is artificial intelligence in machine learning or artificial intelligence in image processing, but there is a fine line between machine learning and artificial intelligence that we need to understand first. Because when we say that a algorithm or a computer is having artificial intelligence, do we really mean artificial intelligence or machine learning? If you look at even the syllabus available on NPTEL or SWAYAM for AI and ML, you will find that the syllabus of AI very closely matches with machine learning. But when we say artificial intelligence, the word itself suggests that there is intelligence hidden inside the algorithm or the computer. Whereas machine learning indicates that we are teaching a machine to extract information, and based on the past information, the machine can predict the future outcomes or any unknown variable. But its output will always be dependent on what it has learned and not what it has actually generated artificially by thinking on its own. Okay, so even though the theme of FDP is artificial intelligence, most of the talks that you have seen, they are focused, or we can say, even though we call it artificial intelligence, but mostly it is machine learning. We are taking some data, teaching it to machine that how to classify it. Basically, image processing is feature extraction and classification. So that is done using machine learning algorithms. And at a later stage, when you have numerous amount of data, you can say that yes, in presence of any random situation, the machine is able to predict the output that we call as artificial intelligence. Okay, so with this introduction, let's start. So what basically is machine intelligence, that we'll see first. So machine intelligence deals with the development of theoretical and algorithmic basis by which useful information about the 3D world can be automatically extracted and analyzed from a single or multiple 2D images of the world. Now, uh, for my talk, I'm restricting machine intelligence specifically for images in 2D, or we can say the 3D data, and not a 1D data, because we can apply the same thing for your ECG signals, EEG signals, which are comprised of 1D signals. Okay, being an image processing person or in the field of research in image processing, I'll stick to the image data only. Okay, so what machine intelligence is, if I give you some image, like currently you're looking at the screen, so you can see two things. Either you can see my face, I'm talking to you. Second one is something on your screen in which a person is there who is giving some action, and there are few cameras which are recording it. And on the left side of the screen here, you can observe that one person is, or one animated person is doing the exact same action. Okay, so what these cameras are doing, they are capturing images from 3D environment. Okay, because that's why if you observe, there are multiple cameras taking the image, so there are multiple 2D images of the real world, and from that either you can form a 3D image that you can see in the left side with blue background. So that is one application, that yes, the machine is able to understand how much is the width of a person. Because when you like, even like you are looking my at my face or my upper body, you don't miss. We are trained to know that yes, I am a skinny person, I might have weight of around 60-65 kg. But to a computer, how can you tell that yes, whether guess the age of the person in the camera or in the photo, or guess the weight of the person in the photo? We as humans are trained from numerous amount of 3D data since our childhood. Since our birth, we are exposed to audio signals, image data, and the child itself learns that yes, if a person is having so and so build quality, he might have some thickness, some weight, some physical attributes. So that is because training, what we as humans perceive is machine learning or physical learning from the training data from our childhood. Like at my home itself, I have a daughter of around 3 years old. So what we do is, we initially while teaching, we say that A is having certain symbol, that some pattern is there, that A, two lines, two slant lines, and one horizontal line. Now, even in future, if the slant angle is different, even the horizontal line is not perfectly horizontal, but a child is able to understand that yes, that is A. That is basically your machine learning. Because when we show to the child that yes, A means two slant lines and one horizontal line, we show it by moving the object randomly, either by flipping the object or keeping it one upside down. Still, the child is able to understand, because that is the training data that we are giving. A, B, C, D, A to Z, 0 to 9, all the data that we are using for training, same thing is interpreted by the child. And then based on the previous knowledge or based on that learning data, some output is predicted by the child. Same thing we are doing for the machine itself. We are giving multiple views of the same image, like you can see in this. And from that, we are telling that we have to tell the machine that there is a person who is standing on his one hand and the background is of plants. That you have to tell the machine, because it's like teaching a child that yes, if you show only some alphabet A, but you don't tell that you pronounce it as A or uppercase A, capital A, lower A. If you don't tell that, you only show the image, that is like you're training in a super unsupervised way. You're not telling that what is the expected outcome. Here in machine learning, we are telling the algorithm that yes, this is the image, and correspondingly there is suitable or corresponding output related to it. So that is machine learning. And from that, depending on the amount of data, like in the previous session itself, Mr. Gohane told that yes, you can have 1,000 or 10,000 images. So after looking, when the machine knows that there are 10,000 images and having certain kind of label, it can learn that yes, anything similar pattern comes in future, it will know what to tell. But as a human or as a coder or as a researcher, you have to tell that yes, what is the expected output? This is your supervised learning. So machine intelligence is also analyzed, or we can classify it into image analysis, scene analysis, and image understanding. That's what we have discussed just now. That yes, depending on the image, you have to analyze. But for that, you have to also tell that in the training data, what exactly is there. Again, scene analysis means what is there in the background, in foreground, and overall understanding from that data. And based on this, there are some related topics that you can pursue for your research, or for your research scholars you can give, which are basically related to image processing, computer graphics, which has emerged drastically in the last 4 to 5 years. Pattern recognition, like, from 90s, we have a reputed journal, pattern recognition in Elsevier, and it is still among the top journals where it is almost impossible to get publication unless it is a very core work, fundamental with all mathematical background. Then you have robotics, but specifically vision in robotics, because whenever a robot is having some arm, it needs to identify what are the dimensions of that object. So robotic vision you have, and finally, after comprising of all these things, after you have a very strong set of training data, you can switch to artificial intelligence. Okay, so basically, what is image processing? We have some 2D images, like nowadays we also have stereoscopic images or 3D images, but for simplicity, let's start with 2D image data, in which you have some M by N image and it is having multiple edges or some information is there. You process it. So generally, like in my MTech days, what we used to do is get an image, extract its quality, means some parameter which indicates about or which gives us perception about the image. Okay, now same thing is if you give, like take example of denoising. You get an image which is having noise, you process it using some transform domain or spatial domain techniques, either remove noise or enhance it, and then you get the output, which is again an image. So for image processing, input is image, output can be image or some feature or some quantitative parameter indicating the quality of that or indicating the
Hello.
physical appearance of that image. Okay, so that is basically your image processing. So what goes under that? So first example, let's take of image enhancement. So if you can see on the left side, the image is blurred. On the right side, the image, the blurriness has been removed. So you have your inverse blur functions. Similarly, the satellite imaging which is there, that is through raster scan, means each row is scanned individually. It's like your CRT monitors which used to be there 20 years ago. So if you have certain kind of image, you know that some information in between can be interpolated. Same thing can be done as you can see in this photo, and a clear picture of earth can be seen. So this is image restoration, or we can also call it as correcting out of focus images. Then you have another application which is image compression, in which you have input image, apply some pre-processing to remove some kind of noise like salt and pepper noise, which causes a lot of distortions during compression. Then go for encoding, you have compressed file. Best example is all of you might be having your smartphones with minimum resolution of camera. The rear camera is 12 megapixel. Nowadays you have even 108 megapixel cameras. So at such a high resolution, if you count the actual size which will be required to store that, can anyone guess that size? Suppose that camera is, let's say for ease of calculation, 100 megapixel camera, and it is taking color images. Can anyone tell or guess how much will be the size of image in bytes or bits? Come on, anyone? Any guess? For 100 megabyte image, any guesses for the size of image which is available when you store it? Or even like you might be having your mobile phone, you can click it now, a 64 megapixel camera, and see the size of image. It if you observe 100 megapixel, I'll give that example itself. So 100 megapixel means there are 100 million pixels. Each pixel will require 3 bytes to store that data. Why 3 bytes? Because red, green, and blue. We are storing it in 3 planes, red, blue, RGB plane. So there are around 300 megabytes of data. But when you store the image, it will have size of around 5 or max 10 MB. So a 300 megabyte of data is being compressed to what you can say 10 megabytes. So 1 by 38 time compression is there. So roughly around 3.33% compression. So that is the power of compression. But for that, again, you require some machine intelligence. Now, for computer graphics based on the image, like if you, as a human, you can tell that this image is of a kettle. But how will the computer understand that how much is the width? As humans, we know that yes, the width will be around 10 to 15 centimeters, or the diameter will be around 20 centimeter for this object. But based on only on the 2D data, or if you have 3D geometric data, if you can construct the 2D images, it will be of very much helpful. So for that, nowadays they take help of the light interaction and the geometric projection from 3D to 2D is used to get this 2D image. So from that, we are moving to the computer vision part. So again, it was like first 2D to 3D, then 3D to 2D. Now from 2D to have 3D geometric data. This is a totally, we can say, magical kind of thing that yes, you have 2D images, but one is able to extract how much will be the depth of image. So you have to construct 3D geometric data from input. Now, mathematically, even logically, it is not possible that we have 2D data and we are able to construct 3D data. That is possible only from learning or machine learning. Or if you tell the machine that yes, if a 2D image is like this, what will be the most probable 3D data? So that is 3D geometric data reconstruction. Okay, so in this picture, you can see that face is there. So only face is extracted and then 3D model of face can be created. Then comes the robotic vision that I told you, that the application of computer vision in robotics, specifically for autonomous robot navigation, inspection, and assembly. And from that, we move on to the pattern recognition, because without that, it is very difficult to understand what exactly is there in the scene. So first, you have to find out what is the pattern available. So it has a very long history, as I told you, that since 1970s itself, we have a dedicated journal for pattern recognition by Elsevier. So research work in this field started in your 1960s, long back, and it is concerned with the recognition and classification of 2D objects, which are specifically 2D images and not 3D data. Because as I told you, it started in 1960s. So at that time, even 2D images, you can say that the images were analog images. The digital images came very much after that. So many classic approaches only worked under very constrained view. And as they are classical statistical based approaches, they are not suitable for 3D objects. So this has triggered much of a research which led to today's field of computer vision. So many pattern recognition principles are used extensively for computer vision. So it's that even though the field is very old, but it has formed the basis to be used in many computer vision applications. And from that, we reach to the artificial intelligence, which is concerned with designing systems that are intelligent and with studying computational aspects of intelligence. So it is used to analyze scenes by computing a symbolic representation of the scene. So it is not like you are giving some image to a computer and telling it that yes, now identify. It won't go identifying pixel by pixel, because if it does that, what will happen is on each pixel there will be some value of 8-bit ranging between 0 to 255, but a single pixel won't be able to indicate what exactly is there in that scene. So you need to group multiple pixels to form an object. So that's where that pattern recognition, if you are having similar pattern, means they belong to a same object, belong to the same object. Right? So it is used to analyze scenes by computing a symbolic representation. This is that symbolic representation which is followed from pattern recognition. You need to find a pattern and then symbolically represent that pattern. So many techniques from artificial intelligence play an important role in many aspects of computer vision. The computer vision, we can say it is considered a subfield of artificial intelligence, because vision is we can say related to stereo images or even 2D images. But artificial intelligence you can apply to 1D, 2D, or n-dimensional data. Just that the computational complexity will go on increasing drastically. So why is computer vision difficult? So basically, it is a many-to-one mapping. A variety of surfaces with different and geometric properties, possibly under different lighting conditions, could lead to identical images. Now, best example is you can see my photo on your screen. Even though I wore a same shirt, but because of the light is going, this is the boundary of separation. And if you give my image to a segmentation algorithm, what it will do is it will extract face and the upper part of my body, it will be segmented in two parts because of light in one part and shadow region in another part. Okay, so as I told you that pixels with similar properties will be grouped, but who will tell the algorithm that there is light? Because of that light, the pixel values has changed, even though they belong to the same category. Okay, so that's why it is many to one mapping. There can be multiple solutions. What if I wear a shirt which is having this pattern, in which this line is there, and one color is darker gray, another is a lighter shade of gray. So the machine has to intelligently identify whether it is the same shirt and because of lighting conditions, things are looking different, or whether the pattern itself is different. Okay, that's why it is very difficult for computer to understand that what exactly is happening. So now what can be the solution? If you can see at the background, a small light is there in behind my in the background of my sitting position. So in that you can observe that a ray of light is there, means a computer can extract that information to understand that yes, the variation in color or pixel values because of the lighting condition. So for that, you need to train the algorithm or train the computer vision algorithm to identify that if light is there, the light will be in a uniform direction. So you can see a uniform pattern is there, which is forming. That's why the vision algorithm has to be computationally intensive to identify all these, we can say, tricks which are available. So that's why we can say that we do not understand the recognition problem because it is so complex. So what are the practical considerations to this? Because a single algorithm won't be able to handle everything. So definitely you need to pose some constraints over this. So what are the constraints to recover the scene? First thing is you have to gather more and more images to train. From that, the algorithm will be able to understand that yes, which is the light region, which is the shadow region, or whether it is a similar pattern. Then based on that, it has to make assumptions about the world. Ability and is the solution computable using reasonable resources? Because computable is find what is there in object, and the algorithm is taking 2 or 3 hours. What is the use of that? So best example is of is you whenever you log into any website, there is something called captcha or recap. Specifically, websites when you try to use the password, and after that it asks you to enter the characters which are available in some characters are not specifically in, we can say, typed font. They are written or they are blurry. But still, as humans, we are able to predict that it is D, G, X, F, lowercase, uppercase, numbers, everything we are able to predict. So basically, can anyone tell what are those? What is that captcha or recaptcha? Why it all emerged? Basically, they are using us to train algorithms. What they do is the same captcha is shown to 10 people, and from 10 people, they ask that what is the written in that captcha, and best of that 10 solutions or 10 people's outcome is taken that yes, if DGXFE is written and more than 5 people respond in the same fashion, the algorithm is able to train that whatever is there in the image is DGXFE. Any queries are there? I think someone has in unmute mode. Okay, do stop me for any queries. Okay. So that capture what is their image by using our intelligence. So basically, it is machine intelligence in the end that is behind all this. This is basically used to digitize the old records. Like you have your Ayurveda there, though they are in some other language, but for English scripts, they are using the captcha and recaptcha information. So using reasonable resources, we are there to train it. And is the solution robust? Itself, are human, like out of 10, even if 5 are able to correctly answer it, then yes, we are uh, helping to make the system robust. So what are the industrial computer vision systems that work very well? So they make strong assumptions about lighting conditions, strong assumptions about position of the object, and strong assumptions about type of the object. So all these things require a lot of data for training. So one such example is shown here, that industrial computer vision application. So what is it is doing is it is identifying which type of object is their system. So you have a camera image acquisition system and one illumination system is there so that the lighting is proper. Because even you might have observed that best even you can try on your own. There is something app in Android called Google Lens. You just point it at particular. I need to tell you what is this. If you want, I can show you a live demo of it. Just a minute. Wait, it's starting. Some participants see one more bit has been opened. See one. Just Yes, it is not open. I'll take a screenshot and share. So in Google app, Google Lens app, you can go and check that yes, what exactly is happening. In that, if you point at any object, it will try to recognize from the numerous amount of training data that it has been given over the course of time. Okay, similarly here also one more system is there that is shown to you as an example. So another example is three processing levels in which there are low level processing which uses standard procedures are applied to improve the image quality. These procedures are required to have no intelligent capabilities, like my topic itself of PhD, that image quality assessment. That can be achieved purely on statistics basis, but nowadays we have image processing based, sorry, artificial intelligence on machine learning based algorithms, which try to predict the quality, and that is the results are even better than the purely statistical based. Okay, so for low level processing, uh, minimum or no intelligence is required for the algorithm. Then you have intermediate level processing, which extracts and characterizes components which are present in the image. So in this, some intelligence might be required. So like if you take an image on left hand side, what you can see is a house is there with a slanting roof. These are there in the front as well as back of house. So you give it to some edge detection algorithm, let's say a canny edge detector with a bias threshold, only in that case you will be able to get this kind of output. So you can see some roof is there, but we are unable to infer what exactly is there. We are not getting any label, but a high level processing is there. Same image, if I give it to a high level processing technique, it will tell that yes, tree, roof, side one, side two, again tree is there, sky is there, roof and side. Again check the image. Roof, side, tree, sky. And again in the background also roof and side is detected. See, roof and side. And clear threshold is there, or means that it is able to understand that the two houses are different. See, the periphery is there, and then based on that, we can say a common tree can be built. That yes, garage, roof, sides means you can call this a garage which is having roof and sides. So they are part of this garage. Bushes, grass are there. House is there which will have roof, side one, side two. So these kind of we can say binarization of tree structure can be done, which is the high level processing. This is what exactly is done in computer vision or vision based applications. So there are recognition cues. Now earlier example was on the easier side. Let's take example of a photo that is there in front of you. And if I ask you to interpret the scene, a human, it can say that yes, there is some ceremony or some function is there, most probably a wedding function is there. So for us, it is very much straightforward that yes, chandelier is there, dining hall is there, and some ceremony is going on way far away from the camera. But for a computer, it will be very difficult because it will say that yes, it is looks something like a hotel. It won't interpret that in the background at the center of the image there is some ceremony going on. Similarly, if you see another image, you give it to a computer vision application, a very interesting result comes. It will tell you that there are three horses and three bandits riding on the horse in the image, and there is one child. But as a human, what you can suggest is there is a child and there is one minivan behind it, which is having painting of three bandits riding on horse. Okay, so what are we able to discern? How are we able to discern reality and an image of reality? And what cues are present in the image and what knowledge do we use to process this image. All these things are important because blindly giving an image to a vision algorithm, it will lead to disastrous outcomes. So for that, the role of color is very much important. So what is this object? If I ask you, it might look like petals of some red colored rose. So the color plays a significant role in recognition. So might this be easier to recognize from a different view? Yes, definitely. Similarly, the image textures can be really helpful to readily recognize the object because you know that panther, then jaguar, leopard, cheetah, all are having specific patterns. All can be done just by analyzing the patterns available in the image or the textures available. Now, The role of shape. Now, if this image is given to a human, he'll say that a child is swinging and a person is pushing or giving uh, force to that swing. But this is just a shadow. From shadow, we are able to recognize what exactly is happening in the background of the scene. But this is not possible for a computer as of now. Now, the role of grouping. Can you identify this?
It's a dog.
Yes. How we are able to do it? Yes, we have grouped multiple blocks. See, the face is there at the left side, legs are there, and we are able to fill those gaps as humans. If you give this to a computer vision algorithm, I don't think you will be able to get any output because it is lacking the texture. See, cheetah from texture it can understand, but here there is no texture. When that spotted dimension dog, that is not clearly visible. Okay, so even though when we say that artificial intelligence, this is simply machine learning, and being humans, we are able to easily understand this because we are having that much amount of training data to connect or fill the missing gap. This you might have even observed in, uh, let's say a doctor is writing some prescription. The pharmacist is able to understand that is what exactly is written, but we are not able to understand that writing, though it is taken as a joke. But basically, what is happening is the pharmacist is able to fill the missing gaps due to large amount of training data because the pharmacist sees similar images on an hourly basis. Okay, similarly, we are able to identify that this is a dog because of the training data. So basically, everything is machine learning. Even we are identifying because we have learned them because our brain has been trained to identify. It is not generating it on its own. So it is basically machine learning and not artificial intelligence. So everything in computer vision, when we say that all the images I have shown that yes, we are able to recognize it, there is some mathematics behind it. Though I won't be going in mathematical analysis, that is covered by a few of our speakers, but it requires lot of calculus, linear algebra, probability statistics, signal processing, projective geometry, computational geometry, optimization theory, control theory, and lastly machine learning, followed by artificial intelligence. So all these things are having a strong mathematical base. So when we say that when I apply a neural network toolbox, like in yesterday's session itself, it was discussed that uh, a box is there, we give input and we get some output. For you have NN tool in MATLAB, it does that. But to understand basically what exactly is happening or to change any of the parameter, you need a strong foundation of these mathematical theories to back it. So where exactly you can use these computer vision applications? They are in industrial inspection, quality control, surveillance and security, face recognition, gesture recognition, space applications, medical image analysis, autonomous vehicles, virtual reality, augmented reality, and many more. Nowadays, we are in the world of augmented reality. From visual inspection, can we tell, like if I give you some image, it consists of a motherboard's image in which is having multiple ICs, maybe processor, RAM, IO peripherals are there, or keyboard controls are there. So from this image, is the algorithm able to identify what exactly the image represents and identify what are the details which are present in this image? That is a tough task. Then there comes character recognition, like demodulation is written. And if you see the next line, again, same thing is written, but the color is different. But as a human user, we know that it is a sentence or a word is there, so we ignore that color information. We simply read it as demodulation even in the second case. So probably you have uses for this facility in your organizations. Okay, then there comes document handling. You can see there is a part of check which is signed. So you have to extract that yes, which is the region where that signature information is there, and then you have to match that information. So signature verification is done in this way that yes, you have some signature RSALU something is there. So whenever a person, even if I go for my signature, every time the outcome will be different. Okay, and it is based on how much is the height at which I am writing, what is the inclination which I'm using, but the rough structure will look the same. So for signature verification, you cannot do pixel by pixel verification. You have to find out what is the track of pen or in which direction the data flow is there. Also, you have biometric systems in which you have fingerprint data, iris data, face recognition, then gait analysis is there, ECG is there, signature is there. So, n number of applications are there where you can use machine learning followed by artificial intelligence. So how does the basic fingerprint verification? This is just one block I am doing. That even you might be having biometric systems at your institute. Like for us, we are having a face recognition system because of the COVID protocols. We are not going for anything which requires physical contact. So in the initial, like when the machine came, we have to register our face. So we are creating some biometric database, and then every day we are matching our biometric data with the data which is available in the database. Okay. So we are asking that who am I? The machine identifies, takes out feature vectors from our face, tries to match it with the database, whichever is the nearest match, it gives the output. Then you have object recognition. Even if I give you that blacked out objects, you can know that a knife is there, plier is there. Similarly, on right hand side, ancient stapling machine or mouse is there. Okay. So content you can see one this pant and the plier they look very similar because of the number of angles they have. Okay. Other object we can say classification can be like you have some snippet of product and then you are matching it with the database. Same thing can be used for Department of Defense like Army, Air Force or Navy to identify which are the we can say vehicles or armed vehicles which are available with the enemy. Now, interpretation from aerial photography is one such area in which the object which is taken is interpreted. So, based on this scene which is available, you can see that yes, there are few uh, warehouses where things are kept. There are few vehicles which are parked. Specifically, they are boats. So, it is something called uh, seashore area. You can see boats available in that. Then you have autonomous vehicles. Majority of you are from engineering institute where such robotic competitions are held in which line followers or we can say maze solver robots are there. So all these use are we can say the preliminary stages of autonomous vehicles. In India, we do not have that autonomous vehicle. Even if like in US, you have Tesla, which is leading in the autonomous driving. Even Google is having its own car which does that. But for that, you require a proper road which is having accurate marking and indicating that yes, what is the speed limit, what is the next turn which is coming. In India, we lack that facility, so that's why even though you are trying to implement autonomous vehicle, it becomes a tough task in absence of these road markings. Again, traffic monitoring. See, if you observe the image on left, proper marking is there on the road. The distance between marking is uniform, and because of this, it becomes very easy for a computer vision application to do its job. Similarly, for face detection, you require clear faces. Now, the output which are seeing in this presentation is available, can be easily achieved using Viola-Jones algorithm, which basically what does is it applies hard transform to your eyes, and you have your black and white part in the eye. So there it gives the peak because hard transform is basically -1, 1, and -1. So based on that, once you have localized that ways, these are the eyes, you have to go for face recognition. So you have to create a bounding box and then apply the face recognition. So how does this facial recognition system work is it identify what are the eyes, then based on the eyes, the nearby features are extracted and they're mapped. Also, you can extract what is the we can say expression, expression recognition, which can be used for like we can say identification of the person. Then face tracking. Now, if I give you some image, definitely the algorithm is able to find, will be able to find a nearest match, even though there is no face. So you have to apply one, you can say lower bound, lower threshold for this. Okay. Then comes that hand gesture recognition, in which the smart human computer user interfaces are used, or sign language translation is there for the deaf and mute. Specifically, like we have a very large community of deaf and mute person, but due to the lack of communication tools, because even I don't understand the sign language in which the deaf and mute person is speaking. So how can we assist in helping them, or making them part of the complete social circle that we are in? So you can have sign language translators. Currently, mobile phones are there which can be used as camera to interpret what the sign language is being spoken by the deaf and mute person. Then you have human activity recognition, in which if two people are moving, whether there is transfer or there is where any interaction between the two people. If you observe, object is there in the hand of we can say the person one zero, and person one comes, takes that object and moves. So whether the computer vision or the machine learning algorithm is able to identify that. So if you see at the bottom, blue colored person, red colored person one, and green colored is the object, and there is transfer of that object. So if the algorithm is able to segment the image in multiple objects, this is very easily achievable. Then there are medical applications like skin cancer detection, breast cancer detection using simply image processing. Because as we are residing in the tropical region of the world or the earth, skin cancer is a very common phenomenon for us, because the sun's radiation hits us directly, and that creates a lot of problems, specifically in rural areas where they do not use any sunscreen kind of thing. So skin cancer is very much prevalent in the rural area, and because of shyness or some social stigma, they seldom come to hospital and tell that yes, I am having so and so disease. So if any real time application is there which can from image identify that yes, this kind of cancer is present. So basically in India we are having 8 types of cancer. So if anyone, like one of my student has developed one algorithm to identify which of the 8 type of cancer is there, but the student inadvertently left that no cancer scenario. So that work is, we can say, half cooked. So that's why you need supervision to identify that yes, whether an image contains cancer or not, that false negative value should also be present in the data set. Then what we like, this has gained momentum in the last few years, in which you can see one video was also went viral of ex-president of US, Donald Trump. He was saying something, but that was synthetically generated, and though the actual person did not say it, but you can have algorithms in which you feed an image, a face, and then that face will already automatically move and tell that yes, what exactly is there. So that is your face morphing. Also, like this virtual reality or augmented reality, in which you can insert artificial objects into a scene. Okay, so this is all from my side for today. I know I have moved it in a very fast manner. If any queries are there, you can ask. All these are the multiple applications of uh, machine learning and image processing. Okay, any queries from the audience? You can post in chat box, or you can unmute yourself and can tell it. I tried to give you a brief idea that yes, what all things can be possible, because all the talks were very much focused that yes, a specific application is there, but what all things which are possible using the sessions that you have attended, that I tried to portray a picture in front of you.
So, participants, is there any query? Yeah, one question is there, sir.
Yes, satellite
In chat
images are
box.
also used for disaster management, but basically, like even I generally don't recommend my PhD scholars to pursue satellite imaging, because there is a big question of copyright, and it is even though the repositories are there for satellite images, you can find on net on NASA or ISRO's website, but they are very old, and then it will be like you will be working on uh, the ancient data or 10 or 20 years old data. Recent satellite images, they are difficult to get, even though the work, or we can say the scope, is very good in satellite imaging. But again, then benchmarking is a big concern. So for disaster management, definitely you can go for it. But from research perspective, you require standard data set, annotated data set with good quality images. that is a difficult task. Another area in which disaster management can be helped is you can use super resolution to increase the resolution of satellite images, and then they can be used for disaster management. Any other queries?
So, thank you very much, Vipin sir, for this insightful talk. Since there is no queries, we'll end this session here, and participants will meet again at 2:30 in our next session. Thank you, Vipin sir.
Thank you, madam. Thank you, participants.